Hi, in this video we are going to make radar emulator using Python and Arduino from scratch. As in this project would have two parts, one with Python and with the Arduino. Hi, my name is Amit and let's begin with the two sections, that is Python and Arduino, one by one. Let's get started. Let us first start with designing a radar graph in Python, where we'll be using two important libraries, that is matplotlib and numpy. And within matplotlib as well, we are going to use pyplot the most. So let's begin. Matplotlib, import pyplot as plot. And we are also going to import matplotlib itself because matplotlib in the background uses Kinter application for its display. So let's make that as well. Use in the backend, it is going to use Kinter for its display. Now next we are going to need is numpy as np. Yeah, these are the most important libraries. We are also going to use serial library, but let's not import it now. Let's first create our graph first, right? And for graph we are going to use polar plots. So if you are interested in understanding in detail the polar plots, here there is a link in the description box below. I have separate video for that. And here let's begin using that using our graph. So first we are going to need is the figure. So let me create a variable for it. Figure equal to plot dot figure. Okay, plot dot figure. That's it. Here what we'll do is we'll do it debug it simultaneously. Okay, so first we'll be let's show this what we have created. Okay, and shortcut is Control Shift F10. Okay, so we have created a figure, right? But I'm not interested in using this toolbar. So let's get rid of that first. So we have figure dot canvas dot toolbar forget. So with this command I will actually will forget the toolbar. Yeah, that's what it does. Next, I'm interested in giving the name for the figure because that's again an important point for us. So let's do that. Ultrasonic radar. Okay. Yeah, so we are done with the title part. Now I'm also interested in having a fixed size for my display. So let's check this. How does it looks? Yeah, this is good. We have got figure a name, and we don't have the toolbox to the below, right? Yeah. So I'm also interested in having a fixed size window. So let's maximize it. And since it is going to, as we have mentioned, that it is going to use Kinter in the background, so Kinter has got its own command for it. So let's do that first. So here is Kinter manager. Let's create a variable manager plot dot get current figure manager. Okay, with this we are going to get figure manager and manager dot window dot state and here we are going to have zoomed. Okay, perfect. So let's try this out. Yeah, so you could see that it has got zoomed perfectly. So let's do further. Now here I'm going to create a subplot where we'll be having our the rotating angle rotating bar on the figure. So we are going to use this subplot, and while we do a subplot, actually background color and plot color remains the same, and we would not be able to differentiate greatly. So what we'll do is we'll give a figure a color, and for that we have command called face color. So here we have face color. Let's make it as black. Okay, let's make this as black, and let's try this out. Yeah, we have black color window. So next we are going to create a subplot, and let's create a variable for it. So ax is equals to fig dot add subplot. So here we need to mention how many subplots we are going to have in here. So we are going to have one plot only, but we are going to have a special plot, that is polar plot. So if you are interested in understanding polar plot in detail with Matplotlib, I have a separate video for it. You will get a link in the description box below. Check that out as well. So polar plot is going to be true here. True. Yes. And let's give it a face color as well, because if we don't do anything, it is going to remain the white, right? So let's give a face color. And I have a special color code over here, so I'm going to do a copy paste that over here, and we are good to go. Okay. Now next, let's try this out, showing on the figure. Let's plot. Yeah, so we have beautiful circular complete circle as our plot, but we are only interested in having 0 to 180 degree plot, because our servo motor is going to vary from 0 to 180 degree itself. So let's figure out how can we do that. So here we have to set the maximum limits of x and y. I mean, like here there will be radius and angle. Okay, so let's do that first. So first of all, as you could see that the numbers were in black. I'm interested in having them as white. So let's make them white first. So for that we have this command ax dot tick params, and here we can mention their color. So here it is going to be for both the axes, and we want here colors to be white. Okay, so here make a note that here the command is colors. So let's check that out now. Yeah, perfect. So we have all the colors in the white, and we need to also set the number of angles that it show, and the difference between the angles need to be set as well. So let's do that now. So first of all, let's restrict our radius to be some limit, and the angle from 0 to 180 degree only. So let's create a command. So for that we have this command set x limit, y limit, set y limit. So y limit is going to be from 0.00 to maximum. So how much maximum radius do we want to have? Let's create a variable for it, r max. Let's consider it to be 100. So this is going to be from 0 to 100. Perfect. From 0 to 100. And for angle, we are interested in having 0 to n pi itself, 0 to pi itself. So x, let's create a variable here, np dot pi. Now let's plot this first and let's see. Perfect. So we have 0, but the divisions of the angle need to be taken care, and a division between here also need to be taken care. If you want to leave it this way, it is okay, but we can also have control over this. So let's try and understand how can we do that. Okay, so let us fix the position of our subplot, and to do that we have this command set position, and here we need to pass on the coordinates where it is going to show the plot. Okay, let's show now. So here with this you could see it has increased its size. So when we set the position, it is going to increase its size. Now we are interested in having limited number of angles to be shown on the graph, and the distance as well. So for that we have this function called ax dot set arctics, and here we are going to use this numpy function, length space, and here we are interested in having 0.02 r max, right? R max with a distance of 5. And we have this function called set theta grids, and here also we are going to use numpy line space, and here we are interested in giving 180. So with this theta grid, we'll be having how many sections do we want to have? We want to have 10 sections. So with this 180 degrees, it is going to create 10 sections. So here we have 10 sections. Perfect. Yeah. So we are done with the drawing of the graph, right? So let us now create the data which we are going to plot on the graph. So we need angles and theta to be displayed on the graph. So let's create angles first. As this data is going to get from our Arduino board, so angle is going to be np dot arrange, and we are going to arrange it from 0 to 181 with the increment of 1. Okay, with the increment of 1. Let's create thetas. Theta is equals to, now we'll be converting this data into radian. np dot pi divided by 180. So with this we have converted our data into radian format. So here it is good to create the space. Yeah, so we have created our number of thetas. Now next we are interested in the dots for which we are going to represent the distance. So let's call this as poles. Okay, so poles, and we'll be creating we'll be creating the poles plot. Here this is going to remain blank. Line space is going to be blank here. Marker type is going to be circle. Marker color, let us use R, and marker edge color, let's make it as white. Okay, this shows very nice on the graph. Marker width, edge width, let's make it as 1.0, and marker size. Marker size, let's make it as 3.0. Okay, how bright we want this? This is going to be decided with this alpha. Yeah, so similarly we'll be creating line. So let's give it a name as line 1, and ax dot plot. Again, this will remain blank. Color, let's make this as white. Line width, let's make it as 3. Yeah, so we have created line and dots that are going to display the distance. Okay, so pole, and here we are done. Okay, so lastly, we are not going to use this plot.show. We are going to use figure show, and for that we need to draw on the canvas first. So figure dot canvas dot draw. We are going to also need a distance variable which is going to hold all the distances. So let's create a distance variable. Okay, distance. It's better to create a variable like this. NP, let's make this as ones. Length, it is same that of angles. Okay, so we have created distance variable. So here let's create a background for a graph, because this background is going to be used repeatedly to render it fast. Okay, so we have this function. We are going to create this variable ax background. Dot canvas dot box. So with this we have created our background, and we are going to use this in the for loop. So let us first create a for loop. Let us create a infinite loop with while. True. But we need to make sure that we will be exiting this for loop. So let's create a try and exception thing. Except let's create a keyboard interrupt, and within this we are going to make sure that we come out of this loop. So close all. Let's give it a message to user. Keyboard interrupt and break. Okay, perfect. And let's exit the code. So here we have created complete our flow, and let's draw this except an intended block. Okay, here we need to do something first. Print. Okay, and it is going to let's make this as in the main loop. Okay, time dot slip, let's give 2 seconds for it. Exceptional line space. Out here is the line space, but what happened, the error is where the error is. Okay, so here we don't have this function, we want to have style. Okay, line style. Marker. Let's debug these all things first. Everything is here itself. Now what's the problem? So we don't have this function marker color, marker face color. Let's try again. Yeah, so I guess we are in the for loop, so that is because it is continuously in the loop. We need to take care of that first. Now it is not displaying anything. Let's close this out forcefully. Okay, this has got into the infinite loop over here, and we are not interested in this creating an infinite loop blank. So let's what we can do is, how can we test this? By plotting the real-time data from the Arduino board. And to do that, we are going to need serial library so that we can take data from the Arduino and plot that on the graph. So let's start with the serial port. So here, first of all, we need to import the serial library. Then we need to create the serial object. So here we have this command called serial.serial, and comp7 you need to specify what is your COM port number. I have verified it with my hardware that when I connect my Arduino to my computer, this shows me a comp7 number. And if you are interested in understanding the serial port in detail, so I have a separate video for that. I'll give you the link in the description box. If you have any confusion, go check that out. And here we have mentioned that our data is going to come with 9600 baud rate with byte size 8, parity none, and stop bit 1, timeout 1. So timeout 2, that means if there is no data from the Arduino for 2 seconds, it will come out of the serial read function so that it can perform the other functions. Otherwise it could stuck into that read function for the infinite time if you don't give timeout. Okay, so here we have created our serial port called Servo, and now we are going to use this to read our data from the Arduino within the while loop that we have created below. So next we are going to need this function, that is a serial read line, and we are making sure that we are going to send our data from the Arduino with the carrier return and line feed at the end, so that it could sense it as a line, and we are going to take that data into data variable. Now we have already fixed what type of data we are going to send from the Arduino. So when we'll look into the Arduino section, you will get to know more how do we have constructed that data here. So just to let you know here at this point, our data is going to consist 2 parameters, that is the ultrasonic distance and at what angle it is. Okay, so we have 2 parameters that are going to come from the Arduino, and we are going to catch that into this data variable. Now here we need to separate out that data as a data and the distance. So the processing will be doing it here, and in Arduino you will get to know how we have constructed that frame. So here in the data we are now going to have 2 parameters, that is the angle and the distance. But first of all, we will replace all the that is line feed and carrier return with the spaces, so that we'll only have pure data. Okay, so here we split our data, because my data, when it comes into here, I have separated out my data with the comma. So with this regular expression, I could split my data, I could split my string wherever there is comma. Okay, so these values now is going to so this value is going to have my 2 variables, that is angle and distance. So but what might happen is that if I plug in my data, okay, I plug in my Arduino, and if they are in out of sync, I mean like if the frame is already being sent and here we could not capture the complete string, it might happen that we might miss with the comma, right? So that we will not have 2 values within the vals variable. So here we are going to check whether my vals variable is having 2 variables or not, 2 values or not, if when I split that data. Okay, so that's what here is this length for. Now this makes this means that we do not have complete data, so we cannot proceed further plotting that data. So what we'll do, we'll continue with the loop and we'll wait for the next frame to come, so that it will directly jump at this point, and again it will wait for the data. And now when we have complete frame, we for sure going to have 2 values within these values. So we are good to proceed further. Now further, the first variable within the vals is going to be angle, and second is going to be the distance. So we have separated that into say individual variables. Now here we are going to print that out with this print statement if we want, but since finally we don't want to print angle and distances, so let's comment that out. Now next, so here I have this list variable, and on that respective index I'm going to place the distance value right? And this index is going to be decided with the angle. So we have 180 angles, that is from 0 to 180 we have 181 angles, and on the respective angle we are going to place our data, so that while printing on the screen it will print for all the angles, okay? Because we cannot plot angle one by one, though we are going to get angle one by one, but we are going to place that into a complete a string, into list variable, and we are going to plot complete list data, okay? So that we'll have our distances. In a short while you'll get to know how it looks like. So here set data. Now here I need to mention at what angle what should be my data. So theta is nothing but 0 to 180, as we have created earlier this variable, and this is this data which is having all the distances for all the angles, okay? Now next we need to plot that into graph. So here is this function called here we are going to make sure that we are going to plot the background first and then plot our poles, okay? Then plot our poles. So why do we need to do this? Because once we do this for one cycle, actually our data is going to remain in the background. So what we are going to do is we are going to restore our data, restore our frame, restore our background, and on that background now we are going to plot new data, okay? Okay, before plotting directly the poles, we need to create our the line as well on the graph, so that it will look like a radar, okay? So for that we are going to need to draw the line as well. So here I have this variable called line that we earlier created, and then set data. So here we are going to mention what is going to be my line width that is this, and at what angle, okay? This is my angle, and this is my width. So this need to be also displayed on the data. So there we have this function called draw artist, and now we have drawn the poles here, and now we have created the line, and then finally we need to plot that on the canvas. So we have this blit command which is going to which is responsible to show that data on the graph, and finally we will flush our data, so that finally we are going to flush our data so that we will be able to plot our data again, right? So this is what we are going to need to display our data. Now first we will also make sure that whenever I want to exit out of this loop, we should be sure to exit out of this loop, and for that we need to keep on pressing some key so that it comes out of this loop. Now here this keyboard interrupt function is only working is only going to work whenever there is going to be error at this try section. But whenever if there is no error, and if there is no error, so here it won't come out of the loop that we have checked earlier. It was remaining in that infinite loop. So here we need to create that as well. Okay, so to make sure the safe exit, we need to create the way to do the exit. That is, whenever user presses the Q button, this application should exit. So that's what we are going to do now. So here we have this function called keyboard dot is key pressed, and we are going to monitor if the Q key is pressed, okay? So here we'll give a user a message, that is user need to quit the application, and will come out of this main loop, okay? But we also need to make sure that we should always close all the windows. So let's copy this, and let's come here, okay? Plot dot close all, and we need to also import the keyboard library. So import keyboard. Yeah, so this looks good to me. And now next we'll start with the Arduino wiring first, and then we'll code our Arduino as well. Okay, so let's jump on to Arduino section. Here in Arduino section, we have our sketch ready. Here we have servo motor and ultrasonic sensor pin connected to the respective pins. That is, servo pin is connected to 7, trigger 2, and echo pin at number 3. And if you are in confusion that what are these pins, how to interface a servo motor and an ultrasonic sensor, so I have created a separate video for both of them. And if you are interested in understanding in details of their interface, I'll give you the link in the description box. And once you complete that, and when you come back, you will understand it in a much better way. So here, as we have set the pin mode of our respective pins, we need to communicate with our Python with 9600 baud rate. So we have created that as well. We have attached the servo pin. Here we have two loops, for loop, that is from 0 to 180 degree and from 180 to 0 again. So here we'll be giving the angle, and we'll read the ultrasonic distance. So here we have ultrasonic function where we set the trigger pin and get the distance on the echo pin. We convert that into the centimeters, and then here if you could see that I have this angle. Now I'm passing my position, that is my angle, to this respective function, and this position is nothing but an angle with respect to our servo motor. And here with this function I get that angle. I'm passing that angle onto the serial port as it is. Then I'm providing a comma. That's what we have handled in the Python code to separate out the angle and distance. Okay, and in distance we have used the line function so that it is going to send line feed and carrier return as well when it sends the distance. So this makes our frame complete, that is angle comma distance, right? Okay, and we have also already ported this data on our Arduino board, and let's check how the frame is going to look into this particular window. So here I make this serial terminal. Okay, so COM7, my board is not connected. Let's connect the board first. At this point, let's build our hardware. We have this Arduino board, we have ultrasonic sensor and servo motor with us. Let's connect that all, put together, and let's play. So perfect, we have our hardware ready. Now here we have ultrasonic sound sensor mounted on the servo motor, and servo motor is going to run from 0 to 180 and 180 to 0, and at all angles this ultrasonic sensor is going to send us data on our serial monitor. Let's check this out thus on the Arduino serial monitor. Let's keep these windows side by side, this and our serial monitor window, and let's see what data I have here. So we could see that I have angles and I have the distances of the ultrasonic sensor. So with this we have make sure that we have data all for the angles and separated with the comma, right? So perfect. So let's close this out, and we are interested in running our Python code. So let's jump onto our Python code and do that first. Yeah, so we have our data available on the graph as well. So as you could see that it is plotting nice data. So wherever we have this dots, that means there is an obstacle in front. So let's check this window side by side. Okay, it's not possible side by side. Let's because we have fixed its position, so it is not possible for us to see it side by side. But I can make this camera appear here, a little smaller window, so that we could have, you know, data. We could see that with servo motor, no, right? So now if I place my hand in between, now it is going to sense that data and it is going to send me the new data. So perfect, you could see that it has plotted that data over here with the shorter distances. So finally, we have successfully created a Python radar project with Arduino's ultrasonic sensor and servo motor. So this is what it is going to look like. There is a link in the description box to download this code. Check this code and share your experience in the comment section below. And if you like this video, subscribe to my channel for more such videos, and press that bell icon so that you get notified whenever I upload a new videos. Here is the link for servo motor video, and here is the link for ultrasonic sensor video. That is in this video. See you in the next video. Bye bye.